Welcome to Deuterium-Labelled compounds, tracing molecular stories. In this presentation, we'll journey through the fascinating science, synthesis, and applications of deuterium in pharmaceuticals and chemistry, and see how one small isotope makes a big difference. Before any new drug reaches a patient, scientists must answer some crucial questions. Where does the drug go once it's inside the body? How fast is it broken down? And what's left behind after metabolism? These questions define a drug's ADME profile: absorption, distribution, metabolism, and excretion. To visualize these invisible molecular processes, researchers turn to a clever and precise technique: deuterium labeling. Deuterium labeling gives us a powerful way to trace molecular journeys. By replacing regular hydrogen with deuterium, a slightly heavier but stable isotope, scientists can follow molecules as they move through complex systems. This small substitution allows us to see the entire life cycle of a compound, from administration to metabolism to elimination. Deuterium may be subtle, but its impact on pharmaceutical research is anything but small. So, what makes deuterium special? It's an isotope of hydrogen, same one proton, but with an extra neutron. That extra neutron doubles its atomic mass, making deuterium more stable and less reactive. It's completely non-radioactive and safe, found naturally in water at a concentration of about 0.015%. This added stability gives scientists a powerful tracer that behaves chemically like hydrogen, but offers new ways to observe molecular changes. When hydrogen is replaced with deuterium, the resulting CD bond is slightly stronger and vibrates more slowly than the normal CH bond. This subtle difference leads to what's called the kinetic isotope effect. Reactions involving deuterium occur at a slower rate. In biological systems, this means deuterated drugs can resist metabolic breakdown, lasting longer in the body. It's like switching a sprinter for a marathon runner. The same path, but a steadier pace and greater endurance. Creating deuterium-labelled compounds requires precision, and several methods are available. In hydrogen-deuterium exchange, molecules are exposed to deuterium gas or deuterated solvents, often using metal catalysts like palladium or platinum. In reagent-based synthesis, deuterium-rich reagents such as sodium borodeuteride are used to build the molecule with exact placement. Enzymatic or biocatalytic methods gently introduce deuterium into sensitive molecules while preserving structure. And for complex drugs, multi-step synthesis ensures that deuterium stays intact through every transformation. The choice depends on whether you need random labeling or precise site-specific tagging. Deuterium-labelled compounds are essential tools in pharmaceutical research. In pharmacokinetic and metabolic studies, they act as tracers, helping scientists map how a drug is absorbed, distributed, metabolized, and excreted. In mechanistic studies, deuterium helps uncover how reactions occur, whether through substitution, elimination, or rearrangement pathways. They also serve as internal standards in mass spectrometry and as transparent solvents in NMR, allowing for clearer molecular analysis. And most excitingly, deuterium is now shaping the next generation of deuterated pharmaceuticals, designed for improved performance and safety. Replacing hydrogen with deuterium in a drug can transform its behavior inside the body. These drugs break down more slowly, resulting in longer half-life, fewer doses, and lower toxicity. A great example is deutetrabenazine, approved by the FDA in 2017 for Huntington's disease. By substituting specific hydrogens with deuterium, its metabolism slowed significantly, reducing side effects and improving patient convenience. This marks just the beginning of a growing era in deuterium-based medicine. If your research requires deuterium-labelled compounds, you can easily source them. Leading suppliers include Cambridge Isotope Laboratories, Merck, Toronto Research Chemicals, and Sigma Aldrich. For unique molecules, custom synthesis services can provide tailored labelling. You just specify the structure, labelling site, and purity requirements. Once received, handle them carefully, store in airtight containers, label isotopic enrichment clearly, and always verify purity using the certificate of analysis. These steps ensure your isotopic data remains accurate and reliable. The story of deuterium is still unfolding. Beyond pharmaceuticals, deuterium-labelled compounds are enhancing materials science, improving OLED efficiency, and creating more durable polymers. In advanced chemistry, kinetic isotope effect studies and quantum tunneling research are uncovering new frontiers in reaction dynamics. And with the rise of machine learning, the design of isotope-labelled compounds is becoming faster, smarter, and more predictive. Deuterium is the silent storyteller of science, revealing molecular secrets one atom at a time. Thank you for exploring this fascinating world, and as always, stay curious.